In order to understand functions, you have to know how to determine if a given relation is a function, using 4 different representations. Hey there, I'm Tutor June, your guide on this exciting journey into the world of mathematics. Whether you're a student looking to conquer your next math exam, a teacher seeking fresh perspectives, or just a lifelong learner with a passion for numbers, you're in the right place. Our engaging math tutorials turn complex problems into simple solutions. So let's dive right in. In this video, we are going to understand functions by learning how to determine whether a given relation is a function or not. We will explore this concept using 4 different representations: a set of ordered pairs, a mapping diagram, a graph, and an equation. Let us start by understanding the term relation. What are relations? In mathematics, a relation is a way of establishing a connection between 2 sets. To recall, a set is a collection of distinct objects. These objects can be any kind of mathematical entities: numbers, symbols, geometrical shapes, variables, etc. And from the name itself, a relation describes the relationship between the elements of these sets, usually represented as an ordered pair, input, output. The first element is the input, usually denoted as x. The second element is the output, denoted as y. For example, let us say that our 2 sets are the names of children and their corresponding age. We denote set A, or the input set, as the name of the children. Set B, or the output set, as the age. To describe the relationship between these 2 sets, name and age, I can represent the elements of these sets as an ordered pair. Hence, we have the set containing the ordered pairs Alex, 9, Jude, 12, Arlo, 11, and Casey, 11. What is a function? A function is a special type of relation. However, not all relationships work or function. There is a guideline that we need to remember for us to say that a given relation is a function. That is, for every x, or input value, must correspond to only one y, or output value. Is a relation where every x, or input, corresponds to only one y, or output. In other words, a function assigns exactly one or unique value of y to each value of x. You can also think of a function as a machine. If you take an input, and this machine will munch on that input, right? And based on what that input is, it will produce a single unique output. For example, we have the function f of x is equal to x plus 1. If I input 1 to the function, that is, f of 1 is equal to 1 plus 1, and that gives me a value of 2. It gives me a single unique output, which is 2. Now let us try to examine this scenario. Is this relation ordering a coffee for $5 represent a function? Let's find out. we let set A, or the input set, as the amount paid or the amount of money paid, and set B, or the output set, as the number of coffee bought. To describe the relationship of these sets, let us write this as an ordered pair. If you input or pay $5, the output you get is 1 coffee. So 5, 1. If you pay $10, you will get 2 coffees. If you will pay $15, how much coffee will you get? Correct. 3 coffees. So 15, 3, and so on. In this relation, do we have a unique or only one output for each input value? Yes. So, this relation is a function, since there's a unique output for each input. Now, here's a scenario where the given relation is not a function. Imagine you're at a local cafe that has a unique daily special offer. Customers can pay a fixed amount of money to spin a wheel and receive a surprise bonus with their purchase. Here's how the cafe's daily special works. Customers pay $5 to spin the wheel. The wheel has various bonus items such as a free coffee, a pastry, or a 10% discount on the next purchase. Hence, we can let set A, or the input set, as the amount of money paid, and set B, or the output set, as the bonus items received. So in paying $5, we have 3 outputs: a free coffee, a pastry, or a 10% discount coupon. In this scenario, the relationship between the money paid and the bonus item received is not a function, because the input, paying $5, is associated with multiple possible outputs, which are the different bonus items. This means that when you pay $5, you cannot predict exactly which bonus item you will receive. This violates the definition of a function, which requires each input to have a single unique output. Also, this situation demonstrates that a function requires a predictable outcome for each input. We have 4 different representations to determine if a given relation is a function or not. The first one is using the set of ordered pairs. Consider the set containing the ordered pairs -4, 0, -3, 1, 0, 2, 1, 2, 3, 3. Is this relation a function? Yes, since each input value x, -4, -3, 0, 1, and 3, leads to exactly one output value y. 0, 1, -2, 2, and 3. How about the set containing the ordered pairs 2, -15, 7, -2, 9, 4, 9, 11, 10, -9? Is this a function? We can see that the input 9 has 2 different outputs, 4 and 11. Hence, this relation is not a function, since there are more than one outputs for the input 9. Using this example, we can also use the idea that since there are repeated x values with different y values, then this relation is not a function. We can also map the elements of the sets, or using mapping diagrams, as these visually show how each input is connected to an output. So these diagrams will help us to easily determine if the given relation is a function or not. We have 3 types of relations based on how the input and output values are mapped. The first one shows a one-to-one relation. One input is paired to one output, P is paired to x, q is paired to y, r is paired to z. A one-to-one relation is a function, since each input leads to exactly one output. The second one shows a many-to-one relation, since there are two inputs, q and r, that are mapped to only one output, n. A many-to-one relation is also considered a function because it adheres to the fundamental definition of a function. Each input has a unique output. Although the diagram shows two inputs, q and r, that have the same output, n, but no input is associated with more than one output. The last one shows a one-to-many relation. One input, q, is paired to two outputs or multiple outputs, y and z. A one-to-many relation, on the other hand, is not a function because a function requires each input to be associated with exactly one output. In here, input q has two outputs, y and z. So if you can see an input that has more than one line connecting to different outputs, the diagram does not represent a function. Now let us try this. What type of relation is shown in this diagram? And is this relation a function? Although we can see that we have two inputs, -9 and 0, that are mapped to one output, which is -4. And this shows a many-to-one relation. However, we can also see that one input, 5, is connected to two outputs, -1 and 3, which shows a one-to-many relation. Hence, this relation is not a function. We can also use the vertical line test to check whether a graph of a relation is a function or not. The vertical line test says that if a vertical line drawn anywhere on the graph can touch the graph only once, then it is a function. Now, since if I draw a vertical line here to any points on this graph, the vertical line only crosses the graph at one point. Hence, this is a function because the graph passed the vertical line test. On the other hand, if a vertical line drawn anywhere on the graph and can touch the graph more than once, then the relation is not a function. In this graph, since if I draw a vertical line here, the vertical line intersects the graph at more than one point. Specifically in this case, it intersects the graph at 2 points. Hence, the graph does not represent a function because the graph failed the vertical line test, indicating two outputs for a single input. Lastly, let us use the equation itself to determine if a given relation is a function. There are two things that we have to remember here. First, y cannot be raised to an even power. The key to understanding y in equation where y is raised to an even power may not represent a function lies in the definition of a function itself. A function is a relation in which each input x is associated with exactly one output y. When y is raised to an even power, such as in the equation y squared equals x, for each positive value of x, there are two possible values of y, one positive and one negative. This means that a single input x corresponds to two different outputs, which violates the definition of a function. For example, if x equals 4, then y squared equals 4 would have two solutions, y equals 2 and y equals -2. Graphically, this is represented by two horizontal lines at y equals -2 and 2, and such graph will fail the vertical line test because the vertical line will intersect the graph at 2 points, indicating two outputs for a single input. So since the first equation, x equals y squared minus 3y, has a variable y that has an even power of 2, hence, this equation is not a function. Moreover, if we graph this equation, the graph would be a parabola opening to the right. Hence, it will fail the vertical line test. Second, y cannot also be in absolute value bars. Remember, when considering whether an equation represents a function, it's essential to note that for each input, there must be exactly one output. And the absolute value operation, denoted by this symbol, affects this concept because it produces a non-negative result regardless of the sign of the input. For example, if you have an equation like the absolute value of y equals x, this could imply two different functions, y equals x and y equals negative x, depending on the sign of x. And graphically, this would create a V-shaped graph opening to the right, which fails the vertical line test, meaning it has multiple outputs for a single input. Hence, this equation is not a function. So the second equation, the absolute value of y equals x plus 1, is not a function, since again, y cannot be in absolute value bars. We've just gone through some interesting problems today, and now it's your turn. You may pause this video if you'd like. I encourage each and every one of you to give these problems a shot. Remember, the goal here isn't just to find the right answer, but to understand the process and learn along the way. Don't worry if you don't get it right the first time. Mistakes are proof that you're trying, and every attempt brings you to one step closer to a solution. So don't be afraid to make mistakes. Embrace them, learn from them, and keep going. And remember, you're not alone in this journey. We're a community here ready to help and learn from each other. So go ahead, pick up your pen and paper, and once you've given it a try, don't forget to share your solutions and thought process in the comment section. We all learn better when we learn together. Keep learning, keep growing, and most importantly, keep enjoying the process. You've got this. If you're new to this channel, check out this video right here for more math tutorials. And don't forget to hit that like button if you find this video helpful. And subscribe to TutorJun TV for more exciting math tutorials. Thank you for watching, and I'll see you in the next video.